Alright, so let's move on to problem number 10. So we have a toy truck moving off the edge of a table that is 1.5 meters high and it lands 0.4 meters from the base of the table. So just go ahead and read this problem. I'm going to go ahead and get it drawn. So here's a truck. It's a very beautiful little trucky. And what's happening is it gets launched off a table and it actually goes horizontally. And you know what? I just want to correct that. I don't like the way that looks. Because it actually should be falling at a little bit of a better rate there. So it's falling, and as it falls, it hits the ground. And so this is where the truck goes, falls and hits the ground. Now, once again, let's get some letters labeled. So what are we going to have here? We're going to have y naught equals 1.25. We're going to have y equals 0. We have x naught equals 0. And we actually land a distance x equals 0.40 meters from the base. So in other words, this total distance from here to here that I'm drawing just now, this is 0, this is 0.40 meters. We want to know the time that passed between the moment the car left the table and the moment it hit the floor. So let's go ahead and actually get some equations set up. So first, all the equations we need are y equals negative 1/2 gt squared plus v naught yt plus y naught. And be very careful in how you copy each of these letters. Vy squared equals v naught y squared minus 2g times y minus y naught. And finally, Vy equals negative gt plus Vy naught. These are all the y direction equations. And then in the x direction, of course, we have x equals V naught xt plus x naught. Now, we want to know the time that passed, so let's look at the y equations. Okay, now here's the problem. I know a couple things, but not enough to use the simplest equation possible. So I know that v naught in the y direction equals 0. I know that since I'm moving horizontally, v naught x is not equal to 0, but I don't know what it is. So now let's look at these equations. Let's just start with the y equations to get time to try to plug in and get numbers. So I know that y is 0. I know that g is negative 9.8, or g is 9.8. I already got the negative sign there. V naught y is 0, and y naught is 1.25. So really my only unknown is t, so let's go ahead and actually plug in and solve. So I have 0 equals negative 1/2 times g is negative 4.9 t squared plus 1.25. So t ends up being 1.25 divided by 4.9, all of that under a square root. So let's go ahead and actually get that then. So 1.25 divided by 4.9. All that under a square root gives me about 1/2 second. So 0.551 seconds, really. And we want to know the horizontal velocity of the car when it hit the ground. So x equals v naught xt plus x naught. We have 0.4 equals v naught x times 0.51 plus 0. So we're actually going to then solve for v naught x from here. And when we do that, we're going to actually end up getting that v naught x is about equal to 0.79 meters per second. So that's pretty much the answer to number 10. Now let's move on and take a look at number 11. All right, so this is it. Let's highlight everything here. And now we get rid of that. So problem number 11. This is a great problem. Actually, no, I don't want to mess with it. So problem number 11. It says we have a hawk in level flight. It's got a speed of 20.0 meters per second. Okay. And it is, again, we have y naught equal to 135 meters, and we have y equal to 0 at the bottom. And we have x naught equal to 0. And we want to know this point out here where the fish is going to just fall and land at x. Marks the spot. Oh. Okay. Now, it says the hawk's horizontal speed is 20 meters per second. How far out of the drop point will the fish land? We need the time. So now we've done about 3 problems like this. So we can get in this trend of realizing, hey, whenever I got these horizontal problems, I'm going to use the y equation to get the time. So y equals negative 1/2 gt squared plus v naught yt plus y naught. We realize this is 0, we realize this is 0, and this is 135. So we can just kind of fast forward here and get negative 135 equals negative 4.9 t squared. And then we can actually go ahead and solve. So 135 divided by 4.9. Whoops. So 135 divided by 4.9. We take the square root of that. And we end up getting a time of 5.24 seconds. Now we want to know how far ahead of the drop point the fish will land, so we're going to use this time to get that. So in other words, we're going to use x equals v naught xt plus x naught. So that means x is going to end up being 20 times 5.24. And actually I should have rounded a little better. This is actually 5.25. So when we go ahead and get x, that actually ends up being 104.97 meters. Beautiful. So that's it for that problem. Okay, so we're just going to continue doing these problems because I want you to have lots and lots and lots of examples. So we just check the time here and see how much time we have. Great, so we're about halfway through. So we're going to go ahead and take a look at problem number 12. So same idea. Now I'm going to be a little quicker with number 12 because the expectation is that you're really getting used to these problems. So for number 12, we get a pistol firing horizontally. So here's a target. 200 meters per second. The bullet's velocity, how long does that so? And we want to know, so the bullet's going to hit here below. So we know that this y is 0. We don't know what y naught is. And we know that x naught is 0 and that x final is 120. So how long does it take the bullet to get to the target? How far below the target does the bullet hit? So we have all the x information here. So let's use the x equation. So x equals v naught xt plus x naught. Okay. See, what I did here is I looked at all these numbers. This is the reason I actually draw in all these letters and say, hey, you know, I noticed there's a big trend in that I seem to know here, and I should have labeled this a little better, that this is v naught x. So I see all these x letters. There's an x letter, x, x. This problem is very xy. So there we go. And we go ahead and put in all the x stuff into the equations because that's what I have available. So why don't I go ahead and get the time, even before I worry about y. Okay, so I have 120 equals 200t plus 0, so I'm going to end up getting 120 divided by 200, so that cancels. Let's see, so that's 3 times 4 is 12, 5 times 4 is 20, so 0.6 seconds. And now I can figure out how long it takes it to fall, or how far it falls. So I'm going to use y equals 1/2 gt squared, negative 1/2 gt squared, plus v naught yt plus y naught, just picking my equations. And I realize, hey, wait a minute, v naught y is 0, y naught, I don't know what that is, that's what I'm solving for, and y is 0. So I end up getting y naught equals 1/2 times 4.9 times 0.6 squared. So I end up getting a height that it falls from of 0.5. So I'll just go ahead and get these numbers. And I end up getting, it seems a little extreme. Let me just double check it. So 4.9 times 0.6 squared. So 4.9, so 4.9 times 0.6 squared. I'm getting 1.7, this is 1/2 times g times t squared. So this is actually 1/2 times 9.8 times 0.6 squared. This is 1.76 meters. So sorry about that. That should have been it should have been 9.8, not 4.9. So it's 1.76 meters below the target. I'm just so skeptical of this. Let me just double check it one more time. So 0.5, so 0.5 times 9.8 times 0.6 squared. Yeah, wow, 3 feet below the target. So you can be really careful when you aim, I guess. Good to know. All right. So we'll go back here, and we'll take a look at this number 13. So this is a good problem, number 13. So we'll actually take a look at that in our next video.